Good morning, everyone. I will speak about Hadoop Essentials and Hadoop Ecosystem. My name is Ernestas. I'm a professional trainer for more than 10 years, and about half a year we started a journey to learn about big data, about Hadoop, and now I am a certified administrator and developer. A little about our company. We are located in Lithuania, in Vilnius, capital of Lithuania, and very interesting statistics, some small data, yes, where capital of a country nearest to Minsk is Vilnius. And the travel takes about 2.5 hours by train. So it is very, very not a big deal to get to Vilnius or to Minsk. Okay? Our company is certified Cloudera training partner. Cloudera is, I can say, maybe the most popular Hadoop distribution in the world. And we are exclusive Cloudera training partners in Baltic states, in Russia, Ukraine, and I think Belarus in near time. Why we choose Cloudera? Because of its very good training and certification programs. I will speak a little about that. But now I would like to introduce you some essentials about Hadoop. What does it mean? And it is software framework for storing, for processing and analyzing big data. What it means? This framework is distributed. It is scalable, fault-tolerant, and open source. And Hadoop has started about 10 years ago, so it is, we can say, a little mature product. And the name is after the creator of Hadoop, son's toy elephant name. So it's a bit strange name. Yeah? A little about the market. Market research say that every year the market will grow about 50%. Yeah, it is very big growth. And also vendors, different vendors, also work with Hadoop, starting from database vendors. They have data connectors for Hadoop. And with hardware vendors, for example, Intel invested in Cloudera almost $1 billion. It means $1 million for each person working in Cloudera. So the amounts of money and interest in the world about Hadoop is very big, very big. A little about data capacity and price. If we say that we generate much more data, to store the data maybe is not very big problem because cost per gigabyte drops very sharp, and we do not have such problems. But problem appears when we would like to read the data from our disks. So maybe 10 years ago, to read all the data from our disk takes only 2 minutes. Now it is several hours. Yeah? And the problem is how to deal with that data, not how to store the data maybe. And the answer would be it is distributed systems. But in that we have some problems also. It is programming complexity, because programmers have not only deal with data tasks, but also how to program that processes and synchronize your data from different nodes of the cluster. Another thing it is finite branch, because some data are in one cluster node, another data is another cluster node, and the failures. Just imagine that, for example, we have a very good cluster, 2,000 computers in the cluster nodes, and if one computer fails once per 5 years, every day you will have some failure of one node. So the answer may be the failure is unavoidable, but the problem is how to effectively deal with that problem, and Hadoop satisfies this requirement. Very core concepts of Hadoop, what it offers. Applications are written in high-level code. It is not also usual for distributed file systems. For distributed systems. Nodes talk to each other as little as possible. Data is distributed in advance. So data is distributed to cluster nodes before their computation effort. Yeah. Data is replicated for increased reliability and availability. And also, Hadoop is scalable and fault tolerant. We can scale additional nodes very easy. It is not very big problem. Very high level overview how Hadoop works. Initial data when loading to the cluster is split into blocks, and that blocks goes to the nodes, and tasks beginning of the task at least typically works with one single node locally in that node, and we have master program that manage all that nodes. If you would look into the Hadoop, I can distinguish maybe two parts. The first part is, let's say, Hadoop 4 components. Another part may be additional different programs, additional different projects, open source projects. So I will try to explain that two core parts in the beginning. So the first one is Hadoop distributed file system. It is used for storing the data. This file system is virtual. It means it sits on the top of a native file system and provides scalability, fault tolerance, and also efficient processing because of the data locality. How it looks like? For example, we have a very big data file. This data file during loading operation to the cluster is split to the blocks, and each block is replicated several times to different cluster nodes. Default is 3 times, yes, but we can change that information. Yeah, how many times is replicated our data in the cluster. And the node name have the information about that blocks and about that files. How to get and get out the data from the cluster, because we have virtual file system. Not all ordinary programs can work with that. We have Hadoop command line, we have Hadoop API. Also, there are some ecosystem projects for ingesting data to the cluster or to exchange data between Hadoop file system and, for example, relational databases. But we must have some tools. Yes, and a little example. For example, we would like to load from the client 2 files. We have 5-node cluster. And that files are split to the blocks during the loading of the data. And master server, named node server, we have information about what files we have, what blocks belongs to that file, and also in what cluster node what blocks are. And if client asks to get the information from the cluster, he sends information about the file and gets information from the name node. What nodes have the information. And if, example, one node is not available, client can get the information from another dot. It is very easy. Yeah. A little notes about that file system. It is typically blocks. Blocks are about 64 megabytes. You can change that information, but it is rather optimized for large reads of files because of that. And another maybe problem, not problem, but infrastructure reality, this file system is write once. So we can write data, we can delete file and put another copy of that file, but we cannot change the file on the fly. And I will talk a little about MapReduce. It is framework how to process the data in our cluster, and maybe we can say it is some paradigm how to work with data. The MapReduce have three phases. The first phase is named mapper, and each mapper task typically operates in single block in the same node where the block exists. Another part is shuffle and sort. In that phase, system automatically consolidates intermediate data from the mappers, and sorts the data. And the last one, it operates on sorted immediate data and produces the final result. A little example. For example, we would like to count the words in a very big file and just get information, one unique word, and how often he can be was found in that file. So in the first phase, map task gets the row. It makes the key and value pair. So in this particular case, the key is just the name of the word, and the value is just one for every word. Yes, and map task just takes one row and produces that result. So it is the first phase. In the second phase, the data is aggregated, and for the same word, for the same key, we are getting just one row with all values. Yes, some aggregation and consolidation of data, intermediate aggregation. And the last phase, reduce code works on one key, and it can do some things with the values that key has. So in this particular example, we just sum the values, and we will get what the word there was 4 times. Yes. So this paradigm, sometimes, of course, we must have several phases to get meaningful results, but the paradigm is like that. Yeah? Map, shuffle and sort, and reduce phases. Okay? Features of MapReduce. That framework makes automatically all parallelization and distribution of the data. So the programmer just have to write the code of map and reduce tasks. Also sorting and aggregation of data intermediate also is done automatically, and it is also built in fault tolerance. It means if one node fails during the MapReduce, we can start another node and get the same results because the data are distributed, for example, 3 times in our cluster. And in this way, it is key and abstraction for programmers, and MapReduce hides a lot of housekeeping away from the developer. A little about the cluster configuration. In the cluster, we have data nodes, slave nodes, and can store the data in that node. And we have name node, maybe additional name node in high availability configuration. And that name nodes manage the data, metadata about our virtual file system. And for data transformations, for data analysis, we have a resource manager, master node, and when it gets data from the client, gets information about the job, what has to be done, resource manager starts in the slave node, in one of slave nodes, application master, and that application master coordinates all the tasks I have set as map, shuffle, and reduce tasks. Paradigm is very simple. When loading the data to the Hadoop, we are getting some blocks, and that blocks are distributed. And MapReduce aggregates and shuffles and analyzes data in 3 phases. That phases can be maybe took several times. Yes, it is the basic, it's core components, and also in Hadoop we have maybe not Hadoop, but we have a lot of open source different projects. We name them Hadoop Ecosystem, and I would like to speak a little about that products to know maybe something that what is different in that product. So the first one is HBase, Hadoop database. It is based on top of HDFS file system. It can store petabytes of data. It has very good throughput. It can support a lot of read operations, optimized for read, and also handles very well sparse data if we do not have information for every call in the row. Difference between HBase and relational databases. HBase do not support transactions. I can say normal way. It supports one transaction to put or get the data, but row by row. Yes, it supports row-based transactions, but full transaction is not supported. Query language is not SQL. We just get, put, or scan data in our key and value pairs. But the data can be very big, petabytes of data, and read-write throughput is not thousands, but maybe millions of operations per second. Yes. When to use HBase? If you would like just to store the data, you can just use plain Hadoop. If all the data fits in one big node, we can, and we need a lot of transactions, full support of transactions, we can use relational database. But if we have a lot of data and we would like to have a lot of write-read operations, HBase is very suitable for that tasks. Flume, another project. It is service to move large amounts of data in real time. For example, loading the log files from different servers to Hadoop file system. It is distributed, reliable, scalable, extensible, and it can maybe have several layers, and we can get data from different servers, very different information we can get. We can encrypt, compress data during file transfer, during data transfer, and maybe we will have several agents if one agent is not enough to put the data to the file system. It's Flume. Yeah. Another one, workflow engine. Sometimes we have to run several jobs in parallel, or maybe one after another. So is have graphical tool how to make workflow for our, for example, MapReduce different jobs. Scoop is SQL for Hadoop. It can transfer data between relational databases and HDFS. It can allow incremental imports, simple incremental imports, for example, by the key or by the date, and you can exchange data between relational database and HDFS. Yeah? Hive and Pig, very strange names, yes? What is motivation for that tools? To write MapReduce code sometimes is difficult, and it is wrote in Java programming language, and maybe just programmers decided to make another language more advanced or maybe more simple to write, and we have Hive and Pig projects. The Hive project initially was developed by Facebook. Pig initially was developed by Yahoo. What does it mean? These projects do the same MapReduce job, but we can describe the job just using different language. For example, speaking about Hive, programmer can use Hive query language. It's very simple, like language. Just the example of the command to get the information from the Hadoop file system. Yes, from the files. Another one is STIP, and is more how to say, oriented to the scripting language, because on the first we have to describe our data, describe the structure of our data on the fly, and after that we can manipulate with using that information. Yeah. Pig and Hive, so difference between them. The result is the same. The result is MapReduce job sent to the cluster, just not using Java, using another query language. Hive, it is very useful if we know SQL, yes? And in Hive we can make definitions of our data. So we can get virtual tables, virtual structures of our data. Yeah? Impala. We have learned about that a little for our previous speaker. And Impala is high-performance SQL engine for maybe manipulating and getting information about our data. Very similar query language to Hive, but it is faster, most of the time. And Impala stores the data in HDFS, and does not use MapReduce. Does not use MapReduce. It is open source also, and released under Apache software license. Yeah. Which tool to choose? If we have a very difficult maybe problem, very proprietary data types, maybe it is necessary to use MapReduce. If the data is ordinary data, we would like to make faster write, test, or deploy, we can use Pig, Hive, or Impala. And it is very suitable for most analysis and processing tasks. Yeah. Another comparison, little comparison. Advanced for Pig and Hive, we can process data using external scripts. Yeah, Impala just have its language and all, yes, but it is have very good query speed. Also, Apache Spark it is another project, and can be substitute MapReduce in some time. Why it is better? Because it is faster. It is better for iterative algorithms because the data, intermediate data, can be held in RAM, and it is faster to make another step of the data. And API is not only Java, but Python or Scala languages. Yeah. Okay. Spark and MapReduce. So at least in Cloudera, we believed that in some time Spark will change MapReduce paradigm a little, at least. Yes. These things will replace relational databases. Maybe not if that databases are used for intentional purposes. For example, we have not a lot of huge amounts of data. If we would like to get immediate results, if we would like in place identification of data, dates, deletes, inserts, maybe relational database is the solution. But if we have a lot of data, maybe data is read-only and would like to have some scalability, maybe Hadoop is better solution. Okay, a little about the typical data warehouse. Data warehouse, we have data, we have ETL process, extract, transform, load process. We get the data to our data warehouses, maybe to transactional systems, and analyze that information using various tools. What common problems are? First of all, it takes sometimes too much time to get the data from operational power systems. Another problem may be it is too much data for relational databases, and we have to maybe all data just delete from our system, and the problems goes with data quality. Because we have maybe sometimes a very long process in that way. A little case about BlackBerry. They produce daily about 600 terabytes, a huge amount of data. And if they would like to get some answer about, for example, what is usage for its BlackBerry application in some country, some application, it could take several weeks to get that information. So we decided to introduce in that system data warehouse Hadoop instead of Spark, instead of ETL processes. And the result is that Hadoop from one point of view is data warehouse, from another point of view it can store more data, and the data can be maybe a better approach to just analyze the information. And the impact was what the ETL process was reduced in 90%, because we do not need a lot of ETL process when we are getting all the data to Hadoop cluster. Okay? A little about roles that people have in such installations, in Hadoop installations. It is a graphic about how Hadoop is necessary in market, on the job market. Yeah, so that is going very fast, and a lot of people are necessary to implement that things. And some roles and what skills are necessary to have. First of all, we will have system administrators who will install, who will monitor, manage Hadoop software and hardware. So maybe required skill is Linux skill administration, because Cloudera at least have Linux installations. There are another vendors, they have Windows installations, but they are not very common if you use the computer cluster with a lot of computers. Yes? For developers, if they like to deal with MapReduce framework, very useful is Java knowledge and scripting capabilities. For data analysis, maybe it is enough to have Hive, Impala, or big knowledge how to write that code instead of writing MapReduce code. And I'd like to just mention about what trainings are available for Hadoop and from Cloudera University. So, just as I said, for developers, for data analysts, for administrators, and another maybe not so very popular training. But three very popular is developer, administrator, and data analyst. Okay, so I think it is all what I would like to say. And if you would like more information about the trainings, you can see just in Cloudera site or in our data miner company site, also in Russian language. So thank you very much.